Good morning, students. Chapter 8, Electromagnetic Waves. Yes, we have completed theories. Last theory of this chapter is about electromagnetic waves spectrum. Okay, that consists of 7 different types of electromagnetic waves. Yes, this topic you have to learn from textbook because it is totally theoretical based. Electromagnetic wave, its name, range of frequency or wavelength, how it is produced and where they are used, that you have to remember from textbook. Okay, we will see examples and then exercise questions. See, here it is. Example 8.1. You are given a parallel plate capacitor having circular cross-sectional area with radius r is equal to 1 meter and capacitance 1 nanofarad. At time t is equal to 0, it is connected to resistor R is equal to 1 mega ohm in series along with 2 volt battery. It is as shown in figure. See, here it is parallel plate capacitor, but this plate is circular in nature. Okay, yes, battery resistance. What is question? Yes, question is find magnetic field at point P halfway between the center and periphery of plate after t is equal to 10 raised to minus 3 seconds. See, what is question? Here it is. It is periphery. Yes or no? Yes. Okay, so this total distance, its radius is it is 1 meter. Its radius is it is 1 meter. So this total distance is 1 meter. But you have to find magnetic field at this point. From center at distance 0.5 meter. Okay, so at this point, what is magnetic field that you have to find? See, this point P is between two plates of capacitor. This point P is between two plates of capacitor. So, how to find magnetic field at this point? Okay, see, yes, we have to use Maxwell Ampere's law. That is integration B dot dl is equal to it is mu 0 IC plus ID. IC that is conduction current and ID that is displacement current. And for that we have to first of all find displacement current, that is ID. Displacement current, that is ID. That is epsilon 0 d phi upon dt, where phi is flux. Flux is equal to electric field into area. Electric field, then you have to first of all find electric field is equal to yes, we know that it is sigma upon epsilon 0. Sigma means it is q upon a. So yes, first of all you have to find q. What is the equation of q? You are given. See, the charge on capacitor q is equal to Cv 1 minus e raised to minus t upon tau. So what is tau? Tau it is given Rc. So yes, first step to solve this question is first of all find time constant. This tau is called time constant. This time is called time constant. Time constant tau is equal to it is Rc. What is value of R? It is 1 mega ohm. So it is 10 raised to 6. What is value of C? It is nanofarad. So it is 10 raised to minus 9. So here it is 10 raised to minus 3 seconds. Simple. So yes, first of all you have to find this time. Now find charge. A charge on plates of capacitor. Charge on plates of capacitor. So what is the equation of charge? Yes, Q is equal to here it is C 1 minus e raised to minus t upon tau. Simple? Huh? Okay. So yes, it is Q is equal to Cv 1 minus e raised to minus t upon tau. What is value of C? C is obviously it is 10 raised to minus 9 and here it is 9. 2 into 10 raised to minus 9. 1 minus e raised to minus t. What is value of tau? Tau, yes, here it is 10 raised to minus 3. So it is divided by 10 raised to minus 3. Simple? Okay, now take this as it is. Okay, yes, it is value of Q, for example. Now, next, as it is Q, we have to find what is electric field between two plates of parallel plate capacitor. Electric field between two plates of capacitor. In in this region, okay, in this total region. In this total region, what is electric field, that we have to find. We know that equation of electric field. Electric field is sigma upon epsilon 0 is equal to, it is Q upon A epsilon 0. Yes, electric field is produced due to all charges. You know Gauss law. Electric field is produced due to all charges. So yes, to calculate electric field between two plates, you have to consider total charge on this and its total area. Its total area means here I have to consider A is equal to pi r square is equal to pi. What is total radius? Its radius is just 1 meter. So yes, here it is 1 square. So here it is pi. So yes, here is equal to, it is Q upon pi epsilon 0. So it is electric field. Now, as we have to find, okay, what is magnetic field at point P. So yes, we have to use Ampere Maxwell Law. For that you have to consider Ampere loop. At distance, at this point you have to find magnetic field. Okay, I am giving name R dash. R dash is equal to, it is nothing but, R dash is equal to, it is nothing but 0.5 meter. So yes, you have to consider 1 Ampere loop like this. You have to consider 1 Ampere loop like this, having radius R dash. Okay, so now we will find what is flux passing from this loop. Okay, so yes, how to find flux passing from this loop. Okay, so take a loop of radius R dash parallel to plates. Parallel to plates. Clear about this? Parallel to plates. Now we will find what is flux passing from it. Now we will find what is flux passing from it. Okay, flux passing from it. Electric flux passing from loop. Okay, so electric flux passing from loop, that is phi E is equal to, we know that it is E into A. And see what is angle between E and A. This loop is parallel to this plate. Obviously area vector is perpendicular. Yes or no? So electric field and area vector, they both will be in same direction. So you can write directly it is E into A. E, where is E? Where is E? E here it is, yes. It is E is equal to, it is Q upon pi epsilon 0. A means here it is pi r dash. Yes, pi r dash. Clear about this? This only. Okay, so yes, is equal to, it is Q upon pi epsilon 0. Yes, this pi. Okay, then it is Q upon epsilon 0. R dash means it is 0.5 whole square, or you can write it is 1 by 2 whole square, means it is Q upon 4 epsilon 0. Means it is Q upon 4 epsilon 0. Clear about this? Clear about this? So yes, it is simple one. Okay, how to find E? Pi E is equal to EA. E means Q upon pi epsilon 0. A means pi r dash square. You have to put value. It is Q upon 4 epsilon 0. So yes, it is phi E. Now displacement current. What is displacement current? You know equation of displacement current, that is ID. ID is equal to, it is epsilon 0 d phi E upon dt. Yes, we have obtained one equation. Okay, so yes, it is epsilon 0 d upon dt of phi E. Phi E means this whole equation, that is Q upon epsilon, it is Q upon 4 epsilon 0. So see, 1 upon 4 epsilon 0, that is constant out of integration. So epsilon 0 upon 4 epsilon 0 out of integration, differentiation. Here it is d upon dt of Q only. D upon dt of Q only. Clear about this? Clear about this? Okay. So is equal to, it is this cut, this 1 upon 4. D upon dt. D upon dt. What is equation of Q? Yes, here it is equation of Q. Here it is equation of Q. It is, Q means 2 into 10 raised to minus 9. 2 into 10 raised to minus 9 Okay, minus, I'm multiplying this equation inside, okay, minus 2 into 10 raised to minus 9 e raised to minus t divided by 10 raised to minus 3. Simple? Okay, now we have to differentiate. See, it is 1 upon 4. This whole term is constant, so its differentiation is 0. Then here it is minus. Okay, 2 into 10 raised to minus 9. Differentiation of e is same. Okay, so it is e raised to minus t divided by 10 raised to minus 3. But yes, this minus t divided by 10 raised to minus 3, you have to differentiate again with respect to t. So yes, you will get it is minus 1 upon 10 raised to minus 3. So that you have to multiply. Minus 1 upon 10 raised to minus 3. Clear about this? Clear about this? Okay. So now yes, simplify this one. So now simplify this one. It is minus minus will become plus. So it is 1 upon 4. Here it is 2 into 10 raised to minus 6. Okay. E raised to. What is value of time? You have to find at time. This you have to find at time. Yes. T is equal to 10 raised to minus 3. So e raised to minus 10 raised to minus 3 divided by 10 raised to minus 3. So this cut. Simple. It is 2. Here it will be 2. Okay. And 1 by 2 means it is 0.5. So it is equal to it is 0.5 into 0.5 into 10 raised to minus 6 e raised to minus 1. 0.5 into 10 raised to minus 6 into e raised to minus 1. It is displacement current. It is displacement current. Okay, and now one last step. That I will write here. Last step. Okay, see. That last step is according to Maxwell's Ampere law. Integration b dot dl is equal to mu 0 IC plus ID. Mu 0 IC plus ID. Okay. Integration b dot dl, b that we have to find. dl, that is circumference of this loop, and that circumference of loop is 2 pi r dash, is equal to mu 0 IC, as this point P is between two plates of parallel plate capacitor. We know that IC, that is conduction current, that is outside capacitor. Inside capacitor there is only displacement current. So yes, value of IC is 0 and plus here it is value of ID. Clear? So yes, you have to find the 2 by r dash. R dash means yes, here it is 0.5. Mu 0, that you know. ID, here it is. Here it is. So yes, put each and every value in this equation, you will get your answer. Clear about this? So yes, it is one lengthy question. Okay, try to remember steps. Okay, first of all, you have to find time constant, then find charge, then find electric field, then assume one loop, then find flux, then find displacement current, then use this Ampere's circular law with Maxwell's correction. Clear about this? So yes, it is one lengthy question that you have to remember. It is the only lengthy question from this chapter. Clear about this? Write down. Now next question, example 8.2. See, electromagnetic waves having frequency f is equal to 25 megahertz are propagating along x direction. They are propagating along x direction. Electric field at a point is given by 6.3 J volt per meter, means electric field is in y direction. At that point, what is magnetic field? What is magnetic field? See here, we know one relation, that is E upon V is equal to C. So therefore, B is equal to this E upon C. What is value of E? Yes, it is 6.3. Okay, and what is value of C? Yes, value of C is 3 into 10 raised to 8. So yes, you can easily find its answer. Yes, you can easily find its answer. But you also have to find what is direction. See, Electromagnetic wave is propagating along x direction. Electric field vectors, they are in j direction, means y direction. So obviously you have to remember one statement: electric field vectors, magnetic field vectors, and the direction of propagation. These three are mutually perpendicular to each other, and electromagnetic waves propagate. Electromagnetic waves propagate along E cross B. Along E cross B. So if electric field is along J direction, Y direction, what is direction of magnetic field? Electromagnetic waves propagating x direction. Suppose it is x direction. Okay, that it is Y direction and it is Z direction. Okay, so see, here it is E, that is Y direction. If magnetic field is along Z axis, if magnetic field is along Z axis, then and then electromagnetic waves are propagating in x direction. So yes, this magnetic field is along Z axis. So whatever answer you will get here, you have to write like this: K E is equal to blank K caret tesla. Blank K caret tesla. Clear about this? So yes, it is one question. It is very simple. You have to remember only this equation, that is E upon B is equal to C. E upon B is equal to C. Okay, next question. Example 8.3. By is equal to 2 into 10 raised to minus 7 sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t. You have to find what is wavelength and frequency and what is electric field vector. See, first of all, I can write this equation as By is equal to B0 sine kx plus omega t. Yes or no? Yes. So I can write value of B0, that B0 is equal to, it is 2 into 10 raised to minus 7. Another comparison here, K is equal to, it is 0.5 into 10 raised to 3. Now K is equal to, you know, what is value of K? What is value of K? Yes. K means it is 2 pi by lambda is equal to, it is 0.5 into 10 raised to 3. So yes, from this you can easily find what is value of lambda. Simple. And yes, it is. Okay. Then omega is equal to 1.5 into 10 raised to 11. Omega is equal to, it is 2 pi f, that is equal to, it is 1.5 into 10 raised to 11. So yes, f can again easily find. So yes, lambda and frequency, that is wavelength and frequency, that you can easily find with the help of comparison. Okay. Now, as you have to find how to write electric field vectors, you have to first of all find E0. So how to find E0? With the help of same equation, E upon B is equal to C, then E0 upon B0 is equal to C. So therefore E0 is equal to, it is B0 C. Here it is B0 and see that 3 into 10 raised to 8 meter per second you are going to. C is equal to, it is 3 into 10 raised to 8 meter per second. So yes, you can easily find what is value of B0. Then how to write equation? See, magnetic field is along y-axis. Electromagnetic waves, they are propagating along x direction. They are propagating along x direction. Then yes, in which direction is electric field? In which direction is electric field? Again, see here it is x, it is y, it is z. See, as it is function of x, it means waves are propagating in this direction. Okay, magnetic field is along y-axis. B. Then in which direction is electric field? Yes, electric field is in direction in which okay, waves are propagating. In which waves are propagating. And if you remember, whenever we write plus means waves are propagating in decreasing value of x. Waves are propagating in decreasing value of x. Okay, so yes, this direction is possible when electric field is in this direction, magnetic field is in this direction. Clear about this? Again, see here this plus means Waves are propagating in decreasing value of x. Waves are propagating in decreasing value of x. Clear about this? Okay. So yes, electric field. How to write electric field vector? Yes, electric field vector is Ez is equal to E0. Electric field vector are it is Ez is equal to E0 sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 volt per meter. Clear about this? So it is one question which is again based on equations. Okay. Now next question. See what is next question. Example 8.4. Example 8.4. Energy flux. It is 18 watt per centimeter square falls on surface having area 20 centimeter square. Find average force on surface during 30 minutes. Now what is meaning of this? See, watt per centimeter square. What means joule per second? What means joule per second? So it is nothing but intensity. It is nothing but intensity. So yes, intensity I is equal to it is 18 watt per centimeter square. Now we have to find it falls on area 20 centimeter square. Find force on surface during 30 minutes. See, I can write equation of energy. I is equal to U upon 8. That is, intensity is energy per unit area per unit time. Then how to find total energy? Total energy falling on surface. Total energy falling on surface. That is, U is equal to I80. I, what is I? 18 watt per centimeter square. A, 20. T, 30 minute means it is 30 into 60. So yes, your answer will be in joule only. Yes, your answer will be in joule only. Clear about this? So yes, it is total energy. Now you have to remember one characteristics of electromagnetic waves. The momentum imparted on surface. Momentum imparted on surface. Momentum imparted on surface. That is P is equal to U upon C. That is P is equal to U upon C. And then last one that you already know. Okay, that yes, what is force? Okay, average force. Average force on surface. Average force on surface. That is F is equal to it is momentum upon time. It is momentum upon time. Clear about this? So yes, it is one again is equation which is again based on equations. It is based on equations. Clear about this? So yes, first of all, from the equation of intensity, you have to find what is total energy. Then from equation of total energy, find what is momentum. Yes, it is one of the characteristics of electromagnetic waves. Then find force. F is equal to this P upon T. So simple. Yes, all questions are based on equations. So if you remember equation, you can solve such questions easily. Clear about this? Okay. One last example. Example 8.5. See, yes, you have to find what is electric and magnetic field due to a bulb of 100 watt. Bulb which radiates energy in each and every direction. Okay, so yes, a 100 watt bulb which is giving radiation, you have to find electric field and magnetic field at distance 3 meter. Efficiency of bulb is 2.5% and consider it as a point source. So yes, if I consider bulb as point source at distance R is equal to 3 meter at each and every point in all direction. At each and every point in all direction. Yes, I can assume a sphere. So yes, 100 watt bulb at distance 3 meter, efficiency of bulb is 2.5%. So yes, I will find intensity, but to find intensity, first of all, I have to find its area. You see here, consider spherical area of radius 3 meter. Why to consider spherical area of radius 3 meter? Because it is point source, and due to point source, energy is radiated in all direction. Yes, that's why you have to consider spherical radius. Okay, because due to this bulb radiates electromagnetic waves in all direction. So yes, consider spherical area of radius 3 meters. So what is area? Area is equal to, it is obviously it is 4 pi r square, 4 that is 4 pi, that is pi r, you have to take 3 meter. Okay, so yes, first point is you have to find area. Second one, intensity. What is equation of intensity? Intensity is equal to intensity I is equal to, it is power per unit area. It is power per unit area. Okay, so how to find this power per unit area? Power, see, 100 watt bulb and its efficiency is 2.5%. It means how to write this? Okay, I is equal to P means how to write? See, P is equal to 2.5% of 100 watt. Okay, so is equal to, it is 2.5 divided by 100 into this 100. So 100 cancel out. So it is only 2.5. So it is 2.5 divided by its area. Area that you have to find from this. Simple? Yes or no? Yes. So you have to find intensity. Now, again, one of the characteristics of electromagnetic waves, that you know, intensity, equation of intensity. But see here, as this electromagnetic waves contains electric field as well as magnetic field, this intensity is of electric field and magnetic field both. Okay, but if I want to take intensity only due to electric field or magnetic field, then I have to consider it half. Okay. Now, what I have to consider? Okay, total intensity means intensity due to electric field plus intensity due to magnetic field. So I am taking intensity due to electric field. Okay, half of its intensity is due to electric field. So half I is equal to half I. What is equation of I? Yes, we have obtained it is epsilon 0. Is square RMS into C. It is, yes, half I is equal to, it is half epsilon 0 is square RMS into C. Clear about this? So yes, it is equation of intensity. Now this half cut, this half cut. Okay, so yes, we have to make this E square RMS as subject. Then E square RMS is equal to it is I upon epsilon 0. Square RMS is equal to it is square RMS is equal to it is I upon epsilon 0. So E RMS is equal to, it is under root I upon epsilon 0. I you will find from here, epsilon 0 is given, C is given. From this, then you have to find E0. Okay, what is equation of E0? E0 is equal to root 2 E RMS. Okay, so you will get what is value of E0. Then how to find E0? Yes, we know that. What we know that? Okay, B RMS is equal to, it is E RMS upon C, and therefore B0 is equal to, that is, root 2 B RMS. Okay, and from these two values you will get B0, its value is very small comparative to E0. Again, B0 you will get very small comparative to E0. It means that light energy contains most of electric field vectors. Clear about this? Okay, so yes, in wave optics we have considered only electric field vectors as light wave. Any doubt? Okay. Now next question. See what is next question. Exercise 8.1. What is exercise 8.1? You are given parallel plate capacitor. These two plates, each having radius 12 cm, separated by distance d is equal to 5 cm. Charging current is I is equal to 0.15 and it is constant. And you can say it is nothing but it is conduction current IC. Charging current means it is conduction current IC. Okay, yes. First question is what is C? Yes, C is simple. C is equal to epsilon 0 A upon D is equal to, it is epsilon 0 A means it is pi r square. The first question is simple. Second question you have to find a dV upon dt means rate of change of potential. Rate of change of potential that you have to find, dV upon dt. Now how to find this dV upon dt? C. Yes, C is equal to Q upon V. So Q is equal to CV. Differentiate both sides with T. So it is dQ upon dt is equal to D upon dt of V. Sorry, C. D upon dt of C. dQ upon dt is nothing but IC is equal to, it is C constant. It is dV upon dt. So therefore dV upon dt is equal to, it is IC upon C. Simple. IC, here is IC. C. Yes, from this question number 1 you can easily find. Clear about this? So yes, it is one easy question which is again based on the equations. Second question is, okay, how to find ID, that is displacement current. How to find ID displacement current? Again, remember equation of ID displacement current, epsilon 0 d upon dt of phi t, that is electric flux. Yes, ID is equal to epsilon 0 d upon dt. Phi means it is E. Phi means T is EA. Okay, ID it is epsilon 0 d upon dt. E means, yes, E means it is sigma upon, E means it is sigma upon epsilon 0. Here it is T. Any doubt? Any doubt? Okay, now sigma is it is again Q upon T. So epsilon 0 T upon dt. Here it is Q upon A. Here it is A. Epsilon 0 A cut epsilon 0 cut epsilon 0 cut. Again it is nothing but dQ upon dt means it is IC. Means it is IC. So see here in this case ID is equal to IC. Means displacement current is equal to conduction current, and IC, yes, you are given IC, that is 0.15 ampere. Clear about this? So yes, there are some easy questions. Okay, you have to remember equations and relations. Clear about this? Now next question. Next question, exercise 8.2. You are given two parallel plate capacitor, two plates connected with AC source. V is equal to 230 volt. Radius of this plate, that is capital R, radius, it is 6 cm. C is equal to, it is 100 picofarad capacitance. V is equal to 230 volt. Angular frequency 300 radian per second. First, RMS value of conduction current. How to find RMS value of conduction current? So yes, IRMS is equal to, it is VRMS upon Z. So it is question of chapter number 7. Yes, for only capacitor circuit, what is Z? Yes, Z is equal to, it is, here it is VRMS upon XC, because it is only capacitor. Yes, here it is VRMS. XC, what is XC? Yes, XC, yes, you can find XC here. XC is equal to it is 1 upon omega C. Omega and here is C. So simple first question. I RMS is equal to VRMS upon Z. Z is equal to it is XC, capacitive reactance. Capacitive reactance. Clear about this? Okay. Second question is IC is equal to ID? Yes. We have proved in first question. Yes or no? IC is equal to ID. Yes. IC is equal to ID. Then and then Maxwell's correction will be right. Okay. So yes, IC is equal to ID. Number 3. What is magnetic field at 3 cm from axis between plates? Now see what is this question. I will draw this figure again. Enlarged figure, okay? Enlarged figure. Here it is. See, what is radius of this? It is R. Okay? You have to find what is magnetic field at this distance. R is equal to 3 cm. R is equal to 3 cm. To have distance R is equal to 3 cm at each and every point, magnetic field will be same. At distance R is equal to 3 cm from axis, magnetic field will be same at each and every point. Yes, at each and every point. Now how to find magnetic field at this point? First of all, according to current density, first of all I have to find what is current passing from this circuit, from this loop. What is current passing from this loop? Okay, to find current passing from this loop, I will use concept of current density. Okay, current density is same everywhere. Current density is same everywhere. Okay, see this IRMS total current. That total current is passing from this total radius in this region. Yes or no? This IRMS current is passing from this radius capital R. Radius capital R. So what is current passing from this radius small r? Yes, we can use concept of current density. That for this, what is current density? Current density is it is IRMS upon pi r square is equal to, for this what is current? Okay, displacement current ID upon what is current, what is area? It is pi r square. Do you understand this equation? Hello? Do you understand this equation? Okay, current density J is equal to I upon A. J is equal to I upon A. So for this whole disk, this one. For this small loop, this one. Okay, so just make ID as subject, this pi curve. So ID is equal to, it is IRMS R upon R whole square. Simple. It is R upon R whole square. Any doubt? So this is displacement current. Now as you have to find magnetic field at this point, you have to take, yes, Ampere Maxwell's law. Okay, so yes, with the help of Ampere Maxwell law, What is Ampere Maxwell law? Yes, that you know. Okay, Ampere Maxwell law is, here it is. Integration B dot dl is equal to mu 0 IC plus I. Integration B dot dl is equal to mu 0 IC plus I. Between two plates of capacitor, IC is equal to 0. So here it is. We know its answer. Okay, it is B 2 pi r is equal to, here it is mu 0 plus ID. So B is equal to, it is mu 0 ID upon 2 pi r, and therefore B RMS is equal to, it is mu 0 upon 2 pi r. What is ID? Here it is ID. ID is equal to, it is IRMS R upon R. So with the help of this, you can easily find what is value of PRMS, what is value of PRMS, and then from this you can find what is value of P0. P0 is equal to, it is root 2 PRMS. P0 is equal to, it is root 2 PRMS. Clear? So yes, it is one question which is based on, again, equations. Which is based on equations. Clear about this? Write down from it. Next questions. Exercise 8.3. What physical quantity is same for X-ray of lambda is equal to 10 raised to minus 10 meter, means X-rays having wavelength 10 raised to minus 10 meter, red light lambda having wavelength 6600 angstrom, and microwave having lambda is equal to 500 meter. Which physical quantity is same? Yes, which physical quantity is same? See, yes, physical quantity in given medium, that speed is same, and that is c is equal to 3 into 10 raised to 8 meter per second. For each and every electromagnetic waves radiation's speed is 3 into 10 raised to 8 meter per second. Clear about this? Okay. Exercise 8.4. Electromagnetic waves are propagating in z axis. Frequency is 30 megahertz. What is lambda? So yes, we know that c is equal to, it is lambda f. So lambda is equal to, it is c upon f. You can easily find. As electromagnetic wave is propagating in z direction, let electric field is along x-axis and magnetic field is along y-axis. So yes, E cross B, that is I cross J, it will be in z direction. It will be in z direction. Simple. Okay. Next one. Yes. Frequency bandwidth is given. F minimum 7.5 megahertz, F maximum 12 megahertz. You have to find what is lambda minimum and lambda maximum. So yes, again we know that this equation, lambda is equal to c upon f. So lambda minimum is equal to c upon f maximum, and lambda maximum is equal to c upon f minimum. Okay. Next one. Charge particle oscillates with frequency f is equal to 10 raised to 9 hertz. So what is frequency of electromagnetic waves produced? Yes, you have to remember one statement, that frequency of oscillation of charge particle is equal to frequency of electromagnetic waves produced. Frequency of source is equal to frequency of electromagnetic waves. So yes, frequency is 10 raised to 9 hertz. Simple. Okay. Next one is see. See, exercise 8.7. Magnetic field B0, its amplitude is 510 nanotesla. What is E0? Yes, you know equation. That is E0 upon B0 is equal to C. So yes, it is as your homework, you can easily find it. Okay. Next one. E0 is 120 Newton per Coulomb. Frequency is 50 megahertz. What is B0? Yes, first question. B0 is equal to question mark. Again we have equation. E0 upon B0 is equal to C. So B0 is equal to, it is E0 upon C. Simple. Okay, next one. Yes, what is next question? What is next question? What is omega? So yes, omega is 2 pi f. Simple. What is lambda? So yes, C is equal to, it is lambda f. So lambda is equal to, it is C upon f. What is K? So yes, K is equal to, it is 2 pi upon lambda. Okay. Now equations of electric field and magnetic field. Equations of electric field and magnetic field. So yes, let electric field, it is E is equal to EY. So its equation will be E0 sin kx minus omega t j cap. Put each and every value, you will get your answer. And last one is magnetic field, that is B is Bz is equal to, it is B0 sin kx minus omega t k cap. Clear about this? So yes, E0, here it is. B0, you have to find sin, that is sin k, here it is x, that is x. Okay, omegas, here it is, and t, that is t. So yes, again equation based questions, you can solve it easily. Okay. Next question is exercise 8.9. Obtain photon energy in electrovolt in different parts of electromagnetic wave spectrum. Yes, we have equation E is equal to HF. See, whenever you use equation E is equal to HF, your answer will be in Joule. But if you use E is equal to HF upon E, that is 1.6 × 10⁻⁹, you will get your answer in electrovolt. For different region, radio waves frequency, infrared frequency, visible light it is frequency, UV light frequency, X-rays frequency, gamma rays it is frequency. So yes, with the help of this equation, that is E is equal to HF upon E, electrovolt, you have to find photon energy in electrovolt for different parts of electromagnetic wave spectrum. Next question, exercise 8.10. Frequency is given, E0 is given, lambda you have to find, E0 you have to find. So see, simple. E0 upon E0 is equal to C. You can find first question. Then C is equal to lambda F. You can find second question. Prove that rho E is equal to rho B. See, what is energy density of electric field? Rho E half epsilon 0 is square RMS. Rho B, energy density of magnetic field, B square RMS upon 2 mu 0. Now take the ratio. So rho E upon rho B. See this 1/2 cut. It is ERMS upon BRMS whole square, and here it will be epsilon 0, yes, mu 0 epsilon 0. ERMS upon BRMS, it is nothing but C, so it is 6 square, and mu 0 epsilon 0, it is also 6 square, so it is 1. So yes, from this you can say rho E is equal to rho. Simple question? Yes, it is one simple question. That is rho E is equal to, it is rho B. Clear about this? Now next question, exercise 8.11. Exercise 8.11. E is given, electric field vector E is equal to 3.1 cos 1.8y plus 5.4 into 10 raised to 6 t I caret. What is direction of propagation? See, direction of propagation you can identify from this. Why? Y means direction of propagation. Electromagnetic wave propagates. Electromagnetic wave propagates in Y direction. It propagates in Y direction. Simple. Okay. Yes. Then you have to find lambda F and B0. How to find lambda? Yes, you have to compare this equation. E is equal to E0 cos ky plus omega t I caret. So yes, E0, what is value of E0? E0 is 3.1. What is K? K is equal to 1.8. What is omega? It is 5.4 into 10 raised to 6. Yes. Okay. From this, yes, we know one equation. E0 upon E0 is equal to C. So you can easily find what is value of E0. Okay. How to find lambda? K is equal to 2 pi by lambda. You can easily find lambda. Omega, it is 2 pi f. So yes, you can easily find what is value of frequency. So yes, these three questions you can easily find. Okay. Yes, here you have to find these. Okay. Now last, that is what is direction of B? Yes, BE. Here, electromagnetic wave propagates in Y direction. Electric field is in I direction. Then what is direction of magnetic field? Then what is direction of magnetic field? That you have to find out. How to write this equation? See, B is equal to it is B0 cos ky plus omega t. And what is direction of this magnetic field that you have to find here? What is direction? Okay, so yes, this is it for today. question, exercise 8.12. Find percentage of power of 100 watt light bulb is converted to visible region. What is average intensity at 1 meter from bulb and at 10 meter from bulb? See, first of all, what is meaning of this statement? 5% of power of 100 watt light bulb means power of light emitted. P is equal to 5% of 100. Okay, what means it is joule per second? So is equal to it is 5 divided by 100 into 100. So it is equal to it is 5 watt. Okay. Now as this bulb, I can consider this bulb as point source. I can consider bulb as point source. And for point source, in all direction at same distance. In all direction at same distance. Yes, intensity. What is the equation of intensity? I is equal to P upon P. Yes, if it is point source C, then I can assume one surface like this at distance R. Okay, so yes, it is P upon area means it is 4 by R square. It is 4 by R square. Yes, in first question you have to take R is equal to 1 meter. In second case you have to take R is equal to it is 10. Clear? So yes, it is very easy question. You have to first of all understand the meaning of this. If 5% of 100 watt light bulb is converted in visible region. So yes, that is power. Equation of intensity I is equal to is P upon A. Why A is equal to 4 by R square? Because the surface will be spherical in all direction at equal distance. Okay. R is equal to 1, then R is equal to 10. Now next question. See, lambda m into T is equal to 0.29 centimeter Kelvin. Obtain characteristics temperature ranges for different region of spectrum. See, understand question. See, this lambda m into T is equal to 0.29 centimeter Kelvin, or you can write 0.0029 meter Kelvin. It is nothing but Wien's displacement. Wien's displacement law. Wien's displacement. Okay, from this you have to find temperature difference for different region of spectrum. Different region of spectrum means the region is divided in 7 regions. First region, radio waves, then infrared waves, then visible, then ultraviolet, then X-rays, then gamma rays. Okay, 1, 2, 3 is 4, 5 and 6. Clear about this? Clear about this? Okay, and yes, one last one is that is microwaves. Okay, it is, yes, here I can write it is microwaves. So yes, there are 7 different spectrums. Now, for this each and every spectrum, see, I will give you hint for one, that is for visible part. We know that for visible part, wavelength, it is from 4000 angstrom to 8000 angstrom. Yes or no? Yes, 4000 angstrom to 8000 angstrom. So with the help of this equation, first of all, by taking lambda is equal to 4000 angstrom, you have to find with the help of this equation that T is equal to, it is 0.0029 divided by, you have to put value of lambda, 4000 into 10 raised to minus 10. Find value of temperature. Find value of temperature. And for this waveform, that is lambda is equal to it is 8000 angstrom. Again, yes, T is equal to it is 0.0029 divided by it is 8000 into 10 raised to minus 10. Find temperature. To see, it is only for one part, that is visible region. Only for visible region, if you know wavelength, that is from 4000 angstrom to 8000 angstrom, you can easily find what is temperature range. Similarly, you have to find for microwaves, radio waves, infrared region, ultraviolet region, X-rays and gamma rays. Clear? So yes, we have to find temperature ranges for each and every region, region. Clear? Okay, and for each and every region, you will get some relations between temperature and wavelength. Clear? So yes, it is one question which is based on this one equation, that is called Wien's displacement law. Okay, yes, you have to calculate these two temperature as well as, see, it will be range only for visible region. You have to find ranges for another particles also. Clear? Okay, that whole spectrum you have to remember. Students. Okay, for microwaves, what is range of frequency or wavelength? For radio waves, infrared, visible, UV, X-ray, gamma rays, you have to remember ranges of wavelength. Yes, you have to remember. Okay, so yes, temperature difference for a visible and for another 6 region that you have to find. Okay. Next question, 8.14. State the part of electromagnetic spectrum to which each belongs. Means you are given total 5 cases, 5 questions. You have to find this wavelength or this frequency or this energy belongs to which region. For that, students, again, you have to remember spectrum of electromagnetic wave. Okay, for microwave, what is range of frequency or wavelength? For radio waves, ultraviolet light, visible light, you have to remember range of wavelength or frequency, because from that only you can easily understand this. See, it is 21 centimeter wavelength. So yes, if you remember data of wavelength or if you remember data of frequency, suppose, so yes, you can convert this wavelength in frequency. C is equal to lambda f. So yes, if you find f, you can easily find in which region it is. For example, if wavelength is 5000 angstrom, means it is in visible region, because what is range of wavelength for visible region? 4000 angstrom to 8000 angstrom. So if wavelength falls as 5000 angstrom or 6000 angstroms, obviously it is in visible region. So yes, you have to remember that data. Then 1057 megahertz. 1057 megahertz means f is equal to 1057 into 10 raised to 6 hertz. So yes, you have to again, if I say it is 120, so it is 1.057 into 10 raised to 9 hertz. So in which region it falls? That you have to write from given table in your textbook. Okay. Similar same question, 2.7 Kelvin temperature. See, here it is. You have to use lambda m into T is equal to 0.029. So yes, you have to find lambda m 0.0029 divided by, here it is 2.7. So you will get value of lambda. Okay. Number 4, 5890 angstrom to 5890 angstrom. Yes, it is in angstrom. So yes, you can convert in nanometer. Because if your table in your textbook is given in nanometer, so yes, you can easily convert these values in nanometer. Yes, you can easily convert these values in nanometer. Okay, so yes, last question, 14.4 kiloelectrowatt means it is energy. E is equal to 14.4 into 1.6 into 10 raised to minus 19 Joule. Yes, it is Joule. So yes, we know equation of E. E is equal to, it is HF. F is equal to, it is P upon H. What is value of E? It is 14.4 into 1.6 into 10 raised to minus 19 divided by H, that is 6.6245 into 10 raised to minus 34. So yes, you will get value of frequency. And now you have to observe from table, okay, this wavelength, this energy is belong to which region? Clear about this? Okay, so with this chapter is over. Electromagnetic waves, this chapter is over. Yes, last part of theory of this chapter about electromagnetic waves spectrum, that you have to write and remember from your textbook, because it is totally theoretical concept. Okay, you have to remember each and every data, each and every information given. Clear? So yes, for chapter 8 and from my side in 12th, this is it.